AP Calculus ABBC Exam Review Differential Calculus Fundamentals Question 11 Modeling Complex Functions Composition of Functions. Carter has noticed a few quantitative relationships related to the success of his football team and has modeled them with the following functions. All right, so we're going to look at a few functions. So these are the functions that he modeled along with their necessary inputs and their resultant outputs. The first is N, winning percentage. That's written in terms of W. And the output is the average numbers of fans per game. So the winning percentage as a function of the average number of fans per game. Okay. The next function is W, and the input is average daily practice time, and the output that results is winning percentage W of X. Okay. The last function modeled was P, and the input is the number of rainy days during the season, R, and the resultant output, P of R, is the average daily practice time. So we have three functions: average number of fans per game, N of W, winning percentage, W of X, and average daily practice time, P of R. So the question that we're going to answer is, which of the following represents the winning percentage of Carter's team as a function of the number of rainy days during the season? All right. Is it W of P of R? Is it N of P of R? Is it N of W of X? Or is it P of W of X? The function we are looking for takes the number of rainy days as its input and has winning percentage as its output. None of the given functions have both of these features, so we need to compose some of these, okay? So our job is going to be to compose or combine the functions in a necessary combination and order. We need to find the function that takes the number of rainy days during the season as its input, which is P. P is the function that does this. And we need to find the one that has the winning percentage as its output. And that is function W. Okay, so we're going to have to compose these two functions. Note that P takes the number of rainy days R as input and then outputs the average daily practice time, while W takes the average daily practice time as an input and then outputs our outcome of concern, which is the winning percentage. This is what we're interested in, okay? So we're going to compose these two functions, P and W. Therefore, if we take the number of rainy days during the season R and input it into P, and then take the average daily practice time, P of R, and we put that into W, we obtain the winning percentage of Carter's team as a function of the number of rainy days during the season, which the final composition is going to be W of P of R, okay? The expression that represents the winning percentage of Carter's team as a function of the number of rainy days during the season, again, is W of P of R. So that's our final answer.